These videos are for October 13th to October 14th, and we're applying what we learned on October 11th, October 12th. We're going to be looking at the inverse trig functions and how we can apply those. Yeah, so to start, in order to do these, you're going to need a unit circle out so that we can go ahead and solve these. The way this is going to work, we have like 3 sections. I might have 3 videos, one for each section. But essentially, I'm going to do these 4 on the video, and then I have a sheet of paper here covering the rest of them. I'm going to give you solutions to the rest of them. You can work those out. But let's start with arc sine. That should be a square root of 2 over 2. And what we do is we're looking, essentially what this is saying is we want, this is another way of saying this, that sine of theta is equal to square root of 2 over 2. And so we're looking for the value of theta where sine is square root of 2 over 2. And if we look at this, if you look on your unit circle, theta, there's 2 options. Either theta can be pi over 4, because it's positive square root of 2 over 2, or 3 pi over 4. Because sine there is also square root of 2 over 2. But the problem is, like we discussed on October 11th and 12th, is that we want these to be functions. These arc sine, this is also sine inverse. We want these to be functions, and so we restricted the range. And so the range for arc sine was negative pi over 2 to pi over 2. Oh, those should be brackets because we include those for arc sine. And so we're really looking on the right half of the unit circle, if you will. 3 pi over 4 is out of our range, so it can't be 3 pi over 4. So the value of sine inverse or arc sine of square root of 2 over 2 is pi over 4. And that's our solution here. Arc sine of square root of 2 over 2, pi over 4. Another way we could look at this is we can look and say, or sorry, let's go to arc cosine. I think we can see what's happening with arc cosine, all of this, in arc tangent as well. For arc cosine, what's happening is we were trying to find the cosine value where cosine of theta is equal to negative square root of 3 over 2. Again, theta here could equal 5 pi over 6 or 7 pi over 6. But the range for arc cosine, the range we said was from 0 to pi. And 7 pi over 6 falls outside of that range, so it can't be 7 pi over 6. So arc cosine of negative square root of 3 over 2 would be 5 pi over 6. And there's our value. Let's do the similar thing here. Tangent, arc tangent takes a little more work. So we know that that's going to be sine over cosine, and that needs to be 0. Well, if we look on our unit circle, tangent is going to be 0 2 places. Either theta is going to equal 0, or theta is going to equal pi. Well, same thing. Our range for arc tangent is negative pi over 2 to pi over 2. Pi is larger than pi over 2. It's not in our range. And so our value here, because at 0 we have, this is getting tight, 0 over 1. Sine of 0 is 0. Cosine of 0 is 1. You evaluate that, you get 0. So arc tangent of 0 is 0. Okay, hopefully we see what's happening here. Now, for this next one, we need to consider what's happening. First, arc tangent is defined on the right-hand side of the triangle, or unit circle. Looking on the right-hand side. Since arc tangent is negative, it won't be in quadrant 1, it'll be in quadrant 4, since arc tangent is negative. Now that we've seen that, what we can look at is the radian measures in the fourth quadrant that could be negative square root of 3. And if you look at those values, there's two possible radian measures that make sense. Either 11 pi over 6, because we have a square root of 3 over 2 for cosine, or it could be 5 pi over 3, because we have a negative square root of 3 over 2 for sine. So in class we said check one of them. If it's not one, it's going to be the other one. So since 11 pi over 6 is closest to the origin, let's go ahead and try that. So let's say tangent of 11 pi over 6 sine divided by cosine, so that would be negative 1/2 divided by square root of 3 over 2. Since we're great mathematicians, we know to divide fractions, we multiply by the reciprocal, and this would give us that. The 2's would cancel. We can't have a square root in our denominator. And so that's what we would get for tangent of 11 pi over 6. So you can check it if you want, but tangent of 5 pi over 3 works. Okay? Tangent of 5 pi over 3 will actually equal negative square root of 3. Now there's an issue here though. Our range is here for arc tangent. 5 pi over 3, the actual value of 5 pi over 3 is larger than pi over 2. So we need the coterminal angle of 5 pi over 3 that is within our range. And so if you look at the unit circle, pi over 3 is like if you're at 0, you go positive pi over 3, negative pi over 3 would end up at 5 pi over 3. Those are coterminal, 5 pi over 3 and negative pi over 3. And so arc tangent of negative square root of 3 is negative pi over 3. Alright. So essentially what's happening is for arc sine, we're looking at quadrants 1 and 4. In fact, if you want to like, I'll do this up here, arc sine, we're looking at quadrants 1, quadrants 4. Arc cosine, we're looking in quadrants 1 and 2. And this is all based off of what we did last class. If this isn't fresh, I would highly recommend going and reviewing the previous notes. But these are where the inverse trig functions are defined. Sorry. And so we're looking for the angles. I know there's a lot going on here. Hopefully you've been following along. We look for the angles, and in the case where it's not in our range, like here, I'll highlight it in pink, 5 pi over 3 works, but we need the coterminal angle that falls within our range. And that's what's happening here. Cosine and sine should come quicker. All we need to know is which quadrant we're in. What quadrants the arc sine and cosine functions are defined. Arc tangent takes a little bit more work, but I think we can get there. If you have questions, please contact me, ask these about these inverse trig functions. Now I'm going to show you the rest of them. I want you to work those out if you weren't in class. See if you can come up with the same solutions. But these are the solutions for 1 through 6. If you need to pause it, that's fine. And 7 and 8. So I would highly recommend working through those, checking your work, making sure you get to these solutions. Again, if you have questions, please email me, ask those. Part 2 will look at a different type of situation where the inverse trig functions could be used, and we'll look at that in the second video.